Hi and welcome. I'm just going to take a moment to tell you all the programs that I discuss in the video have links in the description below, which you could open, check out for yourself and understand the topic better. And do subscribe if you haven't done so already. We'll take a look at sorting, where we look at sorting algorithms for bubble and insertion sort and count the number of operations while sorting. Now, sorting is arranging the data in some kind of order, and it has gained importance because of the need for reducing the time needed for searching for any kind of information. Sorting can be done in ascending order or descending order. We start by implementing the bubble sort algorithm, where we are going to consider a list or an array of n elements, which we are going to arrange in the ascending order, that is, the smallest at index 0 and the largest element at index n minus 1. We start by comparing the element of index 0 with the index 1 element, and in case index 0 has a smaller element, then it will remain in its place. But if index 0 has a larger element than index 1, then the two will be swapped. Now this will continue with index 1 and 2, where in case index 1 is larger than index 2, the two get swapped. In case index 1 is smaller than index 2, they remain the same. Now this will continue till we reach the end of the list. Now at the end of this first iteration, the largest element will have reached the last index, that is n minus 1. Now, after the first iteration, in the second iteration, we will compare the first n minus 1 elements. That means the last element has been fixed or bubbled to its place, and it will not be considered in the comparisons. At the end of the second iteration, we will now fix the second largest number at the second last place, and then we will not compare that with the rest of the list. After the third iteration, we will only compare n minus 3 elements. At the end of the fourth iteration, we will compare only n minus 4 elements. So this will happen till we reach the last iteration, which is going to be the nth iteration. If there are n elements, there are going to be n iterations, and at the end of the last iterations, there will be no comparison, and the entire list will now be sorted in the ascending order. We start with an example of bubble sort where we are considering a list of elements 6, 2, 7, 3, 5, and 4. In the first iteration, we start with index 0, which is compared to index 1. And since index 0 element is larger than the element at index 1, the two get swapped. When index 1 is compared to index 2, they will not have any change. Index 2 will now get compared to index 3 and the two get swapped. Index 3 and index 4 are compared and the values are swapped. Index 4 and index 5 are compared and the values are now swapped. And we notice that at the end of the first iteration, the largest number has been moved to the last place. That means it has bubbled to the last place. Now, in the next iteration, this will no longer be compared to the rest of the elements. In the second iteration, again, we start by looking at index 0 and comparing it to index 1. No swapping happens. Index 1 is compared to index 2. The two get swapped. Next, index 2 will be compared to index 3 and the two will get swapped. Index 3 will get compared to index 4 and the two will get swapped. And now the second largest number has moved up to the second last place and it now gets fixed there. These two values will no longer be compared to the rest of the elements. In the fourth iteration, index 0 will be compared to index 1. Index 1 to index 2, index 2 to index 3. However, there'll be no swapping happening here because they're already in order. In the fifth iteration, the first two, that is index 0 and index 1 are compared and index 1 and index 2 are compared. Since they're already in order, they will not be swapped. And in the last iteration, only index 0 and index 1 are compared, and the list has been sorted at the end of the sixth iteration. We look at the same example with a program. Here we've taken the same list, assigned it to the variable x. We've used a variable y to take the length of x, and we're going to use two variables to keep track of all the operations. We start with a for loop, which goes from 0 to y minus 1, and it is going to take an iteration every time. We also have an inner loop, which is going to compare each value. So it starts from 0, goes to y minus I minus 1. That's because every time a value is fixed at the end, we do not compare it with the rest of the values. Each time a swap takes place, we are counting that as two operations. So only when the swap takes place, the inner operation is counted. So we start by looking at the first iteration. The outer operation is 1. And once the comparisons have taken place and all the swapping has happened, the inner operations are 8. Notice how the largest value, 7, has come to the end of this list. In the second iteration, we notice that again the comparisons have happened, and now 6 has come to the second last place in the list, and the number of operations is now total 14. We go to the next iteration where 5 is now at the third largest place. In iteration 4, 5, and 6, since no swapping takes place, the inner operations will remain the same. And in the end, the total number of operations that happen here are 22, which is 16 inside, and 6 is the number of iterations. Let us now consider a list which is already sorted. The lowest value is at the first place and the highest at the last. We notice that when we execute this, we will see that all the inner operations are 0. That means no swapping is taking place. Only the iterations that take place are getting counted as operations. So in the end, the number of operations is 6. That is 6 iterations for 6 elements. This is also called a best case. Suppose the list is sorted in the descending order and we have to convert it into the ascending order. Now here, if we execute this, the number of operations will be 36, which is basically the square of the number of elements. We now look at the insertion sort algorithm where we're going to sort a list of n elements in the ascending order. In each iteration of insertion sort, we are going to make one element our key. We start with index 1 as our key element and we compare it to the element at index 0. In case index 0 is larger than index 1, they will be swapped. Otherwise, they'll remain wherever they are. In the second iteration, index 2 will become our key element. It will be compared to index 1 and index 0 and swapped accordingly. In iteration 3, we'll make index 3 our key element, compare it to index 2, 1, and 0 and place it accordingly. In the fourth iteration, the index 4 element will become the key element and it will be compared to index 3, 2, 1, and 0 and placed accordingly. Now this will carry on till it reaches index n minus 1. And at the end of these n iterations, the list will have been sorted. Let's look at insertion sort with an example. We have this list which has elements 5, 1, 6, 2, 4, and 3. We start by making the element at index 1 our key. In this case, the element is also 1. It is compared to the element at index 0, and since that is bigger, it will swap places. In the next iteration, the index 2 will become the key, that is the element 6. It will be compared to 5 and 1, and no swapping will happen in this case. The next key will be index 3, which is the element 2. It is compared with index 2 and index 1 and index 0, and it is swapped two places to be inserted at index 1. In the next iteration, the key will be index 4, which is also the element 4, and it is compared to the index 3, 2, 1, and then inserted at the index 2. The last iteration will make 3 as our key, which is at index 5. It will be compared to index 4, 3, 2, and then inserted at the index 2. And now the list will be sorted at the end of this iteration. We look at the same example with a program. We've assigned that list to a variable x, and we use a variable y to which we assign the length of this list. We also use two variables to keep track of the number of operations. We have a for loop which starts from 1, goes up to y, and we use the variable key to store a key element, that is to begin with the element at index 1 as we discussed in the example. We also take a variable z to which we assign the value I minus 1. Now, sum of operations variable is going to be incremented each time the iteration takes place, and we have a while loop which will check whether the key element is less than any element on its left. And to make sure that the index is always on the left of the key, we have the variable z, which is decrementing each time in this while loop, and we keep decrementing it, but make sure that it is greater than or equal to 0. Now, in case key is less than any element on its left, the swap will take place, and the value of z will be decremented after that. The swap variable will also increment by 2 each time the swap takes place. Otherwise, the key will remain in its position. Now, let's look at the output. We start with this unsorted list. In the first iteration, we've taken the key as the element at index 1, which is 1, and compared it to 5. And once these two are swapped, the number of operations is 2 inner and outer operations, that is the iteration is 1. So total is 3. In the second iteration, the key is 6, which is then going to be compared to 5 and 1. And since no swapping takes place, the inner comparison here are still 2, and the outer operations become 2 because one more iteration has been added. In iteration 3, the key is 2, and that gets swapped 2 places. So we add 4 operations. So each time a swap takes place, 2 operations are added. So here it's taken place 2 times. So we add 4 to the earlier value. So we have total inner comparison operations of 6, and outer is now 3. The next iteration, that is iteration 4, has key, which is at index 4 is 4, and that has made some comparisons on its left, changed or swapped some positions, to which we've added 4 more inner operations, and the outer operations are 4. So in the end, the total number of comparisons in the inner while loop have been 16, while the outer loop has been 5. So the total number of operations comes to 21. In case the list is already sorted, which is also called the best case, then the number of operations will only be the iterations that are happening. There will be no swap. So the inner comparison operations will always be 0. And the total number of operations will end up as 5, which is actually the number of iterations that have taken place because of this outer for loop. In case the list is sorted in the descending order and has to be reversed to an ascending order, let us see the number of operations that will happen. So here we start with the first iteration. The number of operations are 2. The next time it becomes 6. That means in the second iteration we added 4 more operations to the inner comparison operations, and then 6, then 8, and then 10 operations are added in the last iteration. So the total number of operations in this case is 35. So that was a little bit about sorting. I hope you understood. You can always click on the links below to check out anything that you've missed. And I hope to see you soon. Take care.